Hello everyone, and welcome to my presentation entitled IoT Node Behaviors Analysis Under Constrained Environment Using RPL Protocol. I'm Saloua Ibrahimy, a PhD candidate in computer science at Moulay Ismail University, and this work was under the supervision of Dr. Hanane, postdoctoral fellow at Khalifa University, and Dr. Nabil Benamar, full professor at Molay Ismail University in Meknes, Morocco. This presentation is designed based on the following outline: introduction, overview, contribution and scenarios, results and discussion, and finally conclusion. Internet of Things describes the network of physical objects that are embedded with the sensors, softwares, and other technologies to connect and exchange data with other devices and systems over the Internet. The limitation of constrained device like the Internet of Things to some issue, in particular routing of IP packets. The traditional routing protocol like OSPF are not really situated to this situation. This constrained device require a specific routing protocol that allow them reigning over the network. RPL was proposed by a rule working group from IoTF to overcome the limitation of these devices. It's an IPv6 routing protocol for low power and lossy network. RPL also a routing protocol for wireless network with low power consumption and generally suitable to packet loss. Is a proactive protocol based on distance vector and operates on IEEE. It supports multi-hop and many-to-one communication, but also supports one-to-one communication. The main fundamental question this work is handling are how the heterogeneity of the environment impacts the node behaviors and the network service. 2. Does an untrustworthy environment lead always to a network failure? 3. Does the mobility have any positive impact on the network performance? To this end, we propose a generic assessment for IoT devices behavior under different IoT environments. First, homogeneous and heterogeneous environments where two types of devices are used, namely Sky mode and Z1 mode. Second, trustworthy and untrustworthy environments where a rank attack was implemented in the core of the RPL, and finally, the mobility where a randomly waypoint model is adopted. To execute we used Cooja simulator and the Contiki operating system. Cooja is an open source simulator specifically designed for wireless network. The first scenarios is heterogeneous versus homogeneous environment. With the nodes in the homogeneous node, the one of the same type and have similar characteristics. For example, all nodes are of type Sky node, while heterogeneous node refer to various type of the node and with different characteristics. For example, Sky node and Z1 node. Trustworthy versus untrustworthy environments. To create a non-trustworthy environment, we integrate a malicious node in the network, the read node, and the malicious node adopts rank attacker More specifically, the decreased rank attack, where a node announces a faulty rank lower than the real rank to be chosen as a preferred parent. The untrustworthy environment is compared to the trustworthy one, where no malicious node is reigning in the network. Static versus mobile environments. In this scenario, the mobility of IoT devices is constrained, so to simulate mobile node, a random waypoint model is used to select their destination randomly using a uniform velocity while they stop for a short time before moving to the next destination. Here we find some parameters step like the simulator Cooja version 3.0, the mode type Sky and Z1 or both of them, the duration 1000 second and the number of node 10, 20, 30 and 40 node. To assess the effectiveness of the proposed model, a set of routing metrics are constrained as latency, packet loss ratio, energy consumption distribution, and the number of alive nodes. For the heterogeneous and the homogeneous scenarios, this figure indicates the number of alive nodes that are still alive until the end of the simulation. For the network include the 30 node, and the homogeneous and heterogeneous node. We notice that at 300 seconds from the network simulation, the curve starts to decrease toward one node from 700 seconds until 1000 seconds. The distribution of node energy consumption, a small network composed of 20 nodes is constrained as illustrated in this figure. For the heterogeneous environments, we notice that a high variation of energy consumption. This is due to the nature of the deployed node and their proximity to the sink node. For instance, for example, node number 17 and 18 have a higher energy consumption compared to the two curves. The higher variation of energy consumption creates a major gap between the nodes. In this figure, we show clearly that the latency in the homogeneous network is higher than the heterogeneous case for all the network size. The only exception is for the environments which have the size 20 node. In general, the average time between the sending and the receiving packet in the heterogeneous case is higher than the homogeneous case. For the last figure, which illustrates the percentage of packet loss during the communication, the heterogeneous network have a higher packet loss ratio compared to the homogeneous network for all simulation. In a small network of 10 nodes, the packet loss higher due to the distribution of nodes in the interference area. The further from the sink node, more the packets are lost. Compared to the heterogeneous network, homogeneous network lost less packets by up to 10%, while this result is much higher when the network is dense. starting with 30 nodes for both trustworthy and untrustworthy environments. It's noticed that the node in the trustworthy environment keep running for a long time before spending all their energy, as illustrated in this figure. So some of nodes in trustworthy environments spend all their energy after 600 seconds from their communication in the network toward one node. However, the node of untrustworthy scenarios lose their first node at an earlier time after just 200 seconds from 30 node toward 4 node, including the malicious node here. For the energy consumed by each node in the network of 20 nodes, for the trustworthy and the untrustworthy environment constraint is indicated in this second figure. We notice higher variation energy of node number 20 for the untrustworthy environment constraint. The node number 20 is the rank attacker node. This malicious node consumes more energy than the other node because it sends more discovery packets and routing information to the neighboring node, which is justify the higher consumption of energy. The third figure in the left bottom show that in the trustworthy network node spend less time sharing their packets and communicate with each other. In a non-trustworthy network, the latency is higher due to the malicious behavior of the attacker nodes, where it falsifies its rank by announcing a lower rank than its current one. This allows node to communicate with the wrong parent and wait for a long time to receive acknowledgement from the destination. The ratio of packet loss ratio under the trustworthy and the untrustworthy environment constraint is presented in this figure. So we notice that the packet loss is not consistent with the increase in the number of nodes. Thus, the loss of packets is depending on the distribution of nodes in the interference range, the density of the network, and the position of the malicious node. To conclude, the performance of RPL network is significantly impacted by the environment change. So our simulation results showed clearly that the heterogeneous environment negatively affects most of the network metric. Also, in the untrustworthy environment, nodes spend more energy, and the huge number of packets are lost in the mobile environment by up to 92%. Thanks for watching.